everyone, welcome back to another really hard maths question. Let's have a read of it together. So, in this shape, all the angles are multiples of 45 degrees. Some side lengths are given. What is the perimeter of the figure? Okay, find the perimeter of a shape is usually quite easy, but this one is a very weird shape, so it might be a bit hard. But we're given some of the lengths. We're given this length, this length, this length, this length, and this length. So the only missing lengths we have are this diagonal length, and this length here. So if we found those, then the rest of the question would be quite easy. The question is, how are we going to find some of these lengths? Let me draw this out myself. Cool, so this is my very inaccurate drawing of this scenario. So what I'm trying to think about is, how can I use the fact that the angles are 45 degrees? Can I use that to benefit me in any way? And what I've noticed is, this side length here, what would happen if I moved that to the left? So imagine this whole length here, moving it to the left. It would match up with this length here. Since the angle is the same, it can create a full line downwards, right? Another thing I've noticed is, what if I just create a rectangle here and fill that in? Well, then this length would be 5 and this length would be 5. So I can actually create an isosceles triangle where the diagonal goes from this corner point all the way to this corner point, right? So that uses the fact that I've got this distance here, which is 5, and this distance here, which is also 5. Okay, that's very interesting, because now I've split this shape up into this big right-angled triangle and this shape here, which is a parallelogram. And if this length here is 4, then that means this length here is also 4. So we found one of the missing sides, which is a good start. Our next step is to think about, how can we find this diagonal and this diagonal? Well, we've already moved this one along here. So if we were to find this whole diagonal, then that would be the sum of this diagonal and this diagonal. And since I've created a right angled triangle here, I can use Pythagoras to get this diagonal length. Cool. So I've got this side length, which is 5, and this side length, which is 5. So let's do 5 squared plus 5 squared. That gets me 50. So therefore the length of that big diagonal is root 50. And so this distance plus this distance is root 50. Now we can actually add up all the perimeter lengths that we have. So we've got 4 plus 3 plus 1 plus 2 plus 4 so far. Let's add those together. 1 plus 2 plus 3 plus 4 plus 4. We also have this bottom length here, which is just 4. And we've got the addition of this diagonal and this diagonal, which we found to be root 50. So plus root 50. Cool. That is none of these yet, but let's simplify this down and see if we get one of those answers. So 1 plus 2 plus 3, that is 6, plus 3 fours is 12, then plus root 50, and therefore we have 18 plus root 50. Cool. Still not one of these, but I can simplify this third down. This just equals 18 plus root 25 times 2. And since 25 is 5 squared, I can take that 25 out of the square root, and it becomes 5 root 2. Now, is this a possible solution? Yes, it is. It is B. Therefore, our answer is B, and we are done. Cool, so that question was kind of thinking about, how can we manipulate this shape into shapes that are nicer to work with. I realized that I could move this length over here and create a big right angled triangle where the top length and the height are both 5 units, and I used Pythagoras theorem to find this whole diagonal, which is the sum of this small diagonal and this longer diagonal. So if you enjoyed that problem, have a look at the other videos, and I'll see you in the next video. Bye bye.